Welcome everyone. If you're like many of the customers I work with, I'm guessing you have a growing fleet of IoT devices to manage and are struggling to figure out how to manage them at scale. How do you know when a device is having problems or which one needs to be updated? Many of our customers have told us that they're looking at building a web dashboard of their own to be able to more easily manage their fleet. In many cases, they may even need to be able to grant users outside of their IoT org, or maybe even outside of the company, permissions to be able to view and monitor and manage their devices. My name is Martin Searle, Senior AWS IoT Solutions Architect, and today I'm excited to tell you about a new service launching from AWS IoT called Fleet Hub that aims to solve these problems and many others. And so to get started, what I'm going to do is quickly go review the 200 level session information that was provided before. We had a previous session, Introduction to IoT Fleet Hub. That's IoT 209, so check it out if you haven't already. So I'll quickly recap that information and then do a deep dive on a number of important use cases that Fleet Hub aims to solve for. So AWS IoT Fleet Hub for device management is, again, a new service that allows you to centrally monitor your fleet from one easy-to-use dashboard. It requires zero code, it's completely managed, and takes just a few seconds to launch and get started. It's available today in preview, and it will solve a number of potential issues that we think a number of our customers see over and over again. First and foremost is an easy-to-use dashboard to monitor operational state of your devices as well as for any connectivity issues. So this might be devices that are disconnected, that have all of a sudden gone offline for whatever reason, even devices that maybe have authentication issues that can't connect, etc. So the ability to monitor all different types of device states and operational states, all from one easy-to-use dashboard, is one of the core features of the service. Additionally, we also know that customers need to be able to know when their devices are out of date, when devices need to be, have firmware updates sent to them. And so that's another major core feature that we'll be looking at, how to manage that problem. So for looking at use case one, there's a few use cases that we want to solve for. Three main use cases, two related to connectivity and one related to operational states. So if we look at our architecture here, you'll see that this is our architecture, typical architecture that a customer might have when they're building AWS IoT service and building devices for AWS IoT. So you might have on the top right, you might have fleet indexing set up to be able to monitor for connectivity issues. You might have an IoT rule to be able to read shadow rules and telemetry. And then you might have device defender to be able to monitor when devices are sending data that's incorrect or of the incorrect size or incorrect frequency, etc. And all these things and more you would be building into potentially your own web dashboard. On the left-hand side, you see that you have the actual thing that is representation of the actual device that you might be building. And so it would be something like you'd have the telemetry SDK to directly connect to AWS IoT MQTT, the MQTT broker, the Shadow SDK, the Jobs SDK for potentially handling over-the-air updates and handling commands sent down to the device. And all those would be interacting with, in some way, the actual sensors and the data, the actual hardware on the device itself. So let's imagine what kind of problems we might see in this scenario with this setup. So the first thing, of course, is what happens when a sensor is malfunctioning. So it's sending, bad data. In this case, the device is maybe still online, but it's just sending, malformed data or incorrect values, etc. Another one we might see is an application error. So this might be where the application's crashed for some reason, so it's showing us disconnected, without any additional log information or very little log information to go with it. And so everything is crashed except maybe the Jobs SDK for potential, as that might be a separate client, but a way to potentially recover in the future. But the other two SDKs, for example, may have crashed. And then finally, a telemetry alarm. So, this might be something coming in from the device. Maybe it's getting too hot. Maybe it's, something is going on with it that might cause it to go offline, or maybe it might go offline in the future if we don't monitor it correctly. So these are the three of the very common use cases we might see with devices, and we're going to see if we can use AWS IoT Fleet Hub to solve for those today. One other use case we want to solve for, a separate use case than the connectivity use case of the operational state, is what happens when I have devices that are not up to date. How do I make sure that they stay up to date? Monitor that there's some of them may be up to date, some of them may not be up to date. How do I search for them, alarm for those, and then of course update them and send them the correct firmware? And so you might have a fleet that looks like this. Where you have, varying, in my case, I'm, using virtual dispensers for our demo today. And so you'll see I might have dispenser 0.1 or 1.5. And how do I wrangle all these devices so that I know, okay, we need to get all these up to date, which ones are most in need of being updated first? So with that, let's just dive right into the demo.
We'll begin our demo in the AWS IoT Thing Registry, also called the Thing Hub. Now, if you're familiar with AWS IoT, you know that this is the place where you might normally go if you wanted to search for devices, see device details, etc. However, today, we're going to show you how to do all that and more in Fleet Hub. So what I've done for our demo is I've pre-created 50 virtual fragrance dispenser devices and given them dispenser v1 thing types, along with having them publish various shadow states. And these are all devices connected and ready to receive commands just like a regular device. So let's get started with Fleet Hub. To do that, we'll click over on the left-hand side Fleet Hub sidebar option and select Applications. Then we'll select Create Application, at which point we'll be prompted to set up AWS SSO for the first time. This is our single sign-on service that will allow you to create new users separate from normal IAM users. We can then assign these users directly to the Fleet Hub application. So what I want to do here is put in my email address as well as my first and last name. So I'll go ahead and enter that information along with a dummy email address. The next step is configuring the fleet indexing settings inside of the AWS IoT Device Management settings. Fleet Hub uses fleet indexing as one of its core components to help you search for and organize and filter your devices. So in my case, I need to set this up as I haven't done it yet on this account. So when I click on this Manage Indexing link, it's going to actually take me to the settings inside of the IoT console, which will allow me to configure fleet indexing for the first time. That's accomplished by just clicking a few checkboxes where it'll enable fleet indexing, it'll index the shadow as well as the connectivity monitoring. And then I also need to add some additional custom fields inside of Fleet Hub that I want to be able to monitor. So I need to add those here inside of the aggregate fields inside of the fleet indexing settings. In my case, for the demo, I'll go ahead and add in the battery state of charge as well as the firmware version and temperature fields to become aggregate fields inside of fleet indexing and therefore searchable fields inside of Fleet Hub. When I'm done, I'll click Update Search Settings and I'll be ready to go and complete my Fleet Hub setup. So now what I should be able to see in the custom search fields is that those new search fields that I just added in the settings will show up here. I'll hit Next. It will ask me about creating a service role, an IAM service role. So I'll go ahead and leave that to create one. I'll put in the name of my application, in this case just Fleet Hub Demo. And then click Create Application. And now my application is all set up. So at this point, it may actually take a few minutes for the application to become ready, including DNS propagation, etc. So what I'm going to do while I'm waiting for that to happen is actually take one more final step I need to do in order for the application to successfully work. And that is I need to add myself as a user inside of the application. Now remember, the user is going to be my SSO user and not an IAM user. So what's great about that is that you can have a separate set of users with access to Fleet Hub separate from your IAM user management. So if I go ahead and click users here, add users here, you'll see the only user account that is here is the one I just added that in the Fleet Hub setup. So I'll just click that one and select add selected users, and I'm really ready to go now, and then I can click the link to launch Fleet Hub. Now, one thing I should mention is that while this is logging me in, is that I won't need to put in my username and password, and that's because separately off screen I'd already logged into my AWS SSO account. So you'll see it brings me right into Fleet Hub without prompting me for any additional credentials. So here we are. You can see all of my devices. There's about 50 of them, and it looks like they're all connected, which is great, which means the demo is already off to a great start. And so you'll see that on all those random identifiers on the side, those random numbers are all the thing names that I'm using. I'm just using random UUID for my thing name. And you can also see the thing type, dispenser V1, as well as the various shadow values being reported by each device, so everything's looking good. I can also then click Summary on the left-hand side, and here you can see all of my device counts, such as number of devices in whatever groups I have, numbers of devices of different device types I have. If there's a disconnect reason, that would show up on the right-hand side here. Fortunately, as of yet, I don't have any. As you can see, all 50 devices are connected. So let's go back to my device list, and let's see if we can make this device list a little more exciting by causing some of these devices to misbehave. So I'm going to grab a terminal window and bring it on screen so I can run an AWS IoT job that I like to call Order 66. That's for those Star Wars fans out there. And let's see if we can use Fleet Hub to determine what's wrong with them. So let me quickly explain what's going on here in the background while we're waiting for the devices to start acting up. What I just did was I started an AWS IoT job, which sent out a JSON job document to all of my devices with a key of operation and a value of order 66. That's the entire JSON document that was sent out. And so what that means is even though they all got the same instructions, they'll all be acting on those instructions in very different ways. All right, so here you go. You can see that we already have some devices that are acting up. And so what we'll do is in the upper right side, create a filter here that will allow us to dig into which devices are not operating nominally. And we'll start with devices that are disconnected. So we're going to create a filter that says field connected is false. And so when I apply that filter, you'll see that I have 18 devices that are showing disconnected, which is perfect. And they have varying states of why they're not connected. So of the different statuses, one says client initiated disconnect. Looks like one says connection lost. So let's try to figure out why these devices are in this state. And so what I want to do here is maybe filter on one of those disconnect reasons so I can start to hone in on the problem for one of those specific devices. So I'll create a filter using the field disconnect reason, and the value is client initiated disconnect. And so now I'm looking at all the devices that have been disconnected because they initiated the disconnect. So let's look at this filtered list and see what might be the commonality between all these devices. Oh, you know what? It looks like all these devices had a battery state of charge of 1%. So I wonder if what happened maybe is that all these devices ran out of battery and then initiated a shutdown procedure. And so what I could do is go into the shadow here and look at even more details to determine what might be going on with this device. I could even open up the logs using that device ID. I could copy that device ID, open up CloudWatch logs, and then really dig in and find all the logs associated with that device to see if it reported anything before it shut down. I won't do that here, but you can imagine that there's a lot of filtering that we could do with that device ID in our logs and with our telemetry data as well. So let's go back out and take a look at some of the other devices that are acting up. All right, so what we see here is we have the client-initiated disconnects, and we think we have a pretty good idea that those are from the battery dying. So let's clear that filter, and let's just look at just all the disconnected devices again. Okay, so this one says connection lost, but it also has a 1% battery state of charge. So that might just be the battery dying again. Oh, but here's one that says connection lost, but it has a 90% battery. Okay, so that's something different. What's interesting about that one is it has a firmware version of 0.1. It also has a temperature of 14 degrees Celsius, although nothing too special about the temperature, but that version of firmware is a little bit older, so that might have something to do with it. So maybe let's add a filter with the field disconnect reason equaling connection lost and see what we get there. Alright, so we get some new devices that pop out to us. So this one probably has a connection lost because of the batteries again. But okay, here's one that has a 90% battery, another one that has a 10% battery left. And again, all these devices look like they're on 0.1 firmware version. So that might have something to do with it. So after seeing this, we might be wanting to go look at the logs again to see if these devices threw any errors before they crashed or had exceptions that caused them to completely go offline altogether. Now at this point, with these devices completely offline, we have a couple of options. Of course, the first thing we want to do is have someone go on site to reboot the device. But once that device comes back online, we might then use the secure tunneling service to remotely access the device to determine what kind of issues might be needed to fix the device itself. And then, of course, we could run a firmware upgrade to get that device up to the correct version, which we'll be showing you how to do in a moment. But first, let's see if there's any other devices that we want to take a look at to see if they're having issues as well. So just looking at the rest of the devices that are showing as connected as false or disconnected, I'm not seeing any other disconnect reasons other than client-initiated disconnect or connection lost. So for the time being, we'll move on and we'll just look at our full list of devices again, not just the ones that are disconnected. So I'll come up here and clear out this filter. And now we might want to look at the connected devices, but maybe that have shadow states that are not where they're supposed to be. And so when I scroll to the right here, you can see all the custom fields that I created, including all of my shadow fields. And I actually added one additional one called location, which has location information for each of the devices reported by the shadow. And look at this, you can already start to see some patterns here on the right, where the temperature in some locations has reached 100 degrees Celsius. Well, that's pretty hot. We should not have any dispensers that are 100 degrees Celsius. So why don't we go up and see if we can create a filter that will help us give us more information as to why these devices are 100 degrees Celsius and if there's any patterns to them being so hot. So we're going to come up here and say reported temperature is greater than 20. So when I apply that now I see all these devices that are connected, and there's 8 of them that have temperatures greater than 20 degrees Celsius. And let's see, is there a pattern here? Okay, not seeing anything unusual with the battery readings, so hopefully no exploding batteries, but actually look at all those temperatures that are listed at 100 degrees, and they're all in Atlanta. Now, I'm a native Atlantan, so I know it gets pretty hot there, but not that hot. However, the pattern could indicate a problem with a temperature sensor used in that location that could be fixed by maybe a firmware upgrade. We also probably want to set an alarm to know about an issue like this ahead of time in the future. So we've talked about alarming and firmware updates a lot, so let's dive right into firmware update monitoring, alarming, and actually pushing an update. So the first thing I'm going to do is I want to come up here and clear my filters again. Now let's take a look at the firmware versions of all of these devices. So on the right here, you can see the reported firmware version that's being reported to the shadow from the device itself. And you can see that it's kind of all over the place, right? We have 0.1, 1.0, 1.5, and 2.0. So what we want to do is make sure that all of our devices are up to date, so we don't have any more that go offline. So what I'm going to do is I'm going to bring in my terminal window again, and I'm going to run an IoT job just the same way I did the last time, except that instead of it being order 66, it's going to have a different document that is called firmware upgrade that has the details of how to run a firmware upgrade. And because my devices are so fast, you'll see all these go from their current state to 2.0 in just a few seconds. Oh, and there you go. So all the ones that are online, not the offline ones of course, but the online ones are all up to date on 2.0. But we don't want that happening again in the future. So how are we going to proactively monitor these devices and get alarms on them when they're either not up to date or they have a shadow value that's incorrect? So the first thing I need to do is create a filter here that has the firmware version set to anything where it's not the most current version, which is 2.0. So my filter shows me all the devices that are not up to date, which, as expected, are my devices that are offline. So what I'm going to want to do is create an alarm so that I know when these devices or any ones in the future are not up to date and when they get back on the latest firmware. So what I'm going to do is go up here into the top right hand corner and click Create Alarm. Now on this page you'll see that the filter that I created on my last page where I said firmware version that is not 2.0, that carries over to this alarm creation page. Now next what I want to do is I'm going to choose the field, which in this case is going to be the firmware version. This is what the alarm will use to determine if it is an alarm state or not. Then I want to select count. Now this is important because this is going to say how many devices can be in this state before it triggers the alarm. So when I go to the next page here, you'll see that I'm going to specify that as greater than 0. So whenever there are more than 0 devices that meet the firmware version of being more than 2.0, then my alarm will be in an alarm state. So next I'm going to go to the next page here, and it'll ask me to fill out the information for my email list and alarm name. So I'll go ahead and quickly fill that out. And as you can see, pretty straightforward, just a dummy email address here for now. Next page, and then this is the review page. So go ahead and click next and create. And that's it. I'm all set and my alarm has been created. So now I want to go see the alarm detail and see what's going on with it. So you can see I can click on my alarm sidebar icon there, and I can see all of the alarms that I have in my Fleet Hub. I'll click on this firmware out of date one, and it will show me all the metric history for any metrics that have been sent about the alarm, how many devices have been triggered, the details of it. And so it doesn't have enough data right now because it hasn't been sent the data yet. It's still processing it, but as you can see, I can click through all the details. I can see the query for the metric on the dashboard, so it shows me all the devices that meet that criteria for that query. And I can now use that to determine whenever I have devices, in this case, that are not 2.0 and get proactive alarms about it. So today, just to recap, we talked about sensor malfunction, which was the temperature sensor in our case not working correctly, and talked about how to troubleshoot that. We also talked about application errors, which in our case was devices being disconnected completely and throwing exceptions on the device. And then finally, we talked about telemetry alarms, in which in our case was the battery being at 1% charge and then dying. And we looked at how to troubleshoot all those different scenarios using Fleet Hub. And then finally, we also talked about how to run the firmware updates to fix some of those problems and others, again using AWS IoT jobs in conjunction with Fleet Hub. And in the future, that'll actually be something that's all integrated into Fleet Hub as well, as the ability to run actions right inside of Fleet Hub without having to drop to a terminal window or the console for IoT jobs.
Okay, so let's recap what we saw today. So let's first look at the two kind of end-to-end pieces there, the two core pieces that we were discussing. So on the one side, we have our actual dispenser device, which you saw had all kinds of issues, and we need to be able to monitor all those different types of issues with the device. And on the other end of the spectrum, other side, on the cloud side, you have the Fleet Hub side. And so how are these going to interact with each other? What does this architecture look like? So first and foremost, as I mentioned, AWS IoT Fleet Hub uses fleet indexing, AWS IoT fleet indexing. And so it's going to interact with fleet indexing, which in turn is going to interact with the AWS IoT Thing Registry, as well as the AWS IoT Device Shadow Service. And so both of these things are going to be updated from either side. The dispenser device will update the thing registry and the device shadow, and then Fleet Hub will read that and build that all into that nice dashboard you saw a minute ago. Now in the future, as I mentioned, we're going to be adding some new things. Those are planned things that we're hoping to come out with. And so the first one, of course, is the job service integration, so that you can send actions directly to your devices from Fleet Hub. And the next thing that is on the list of things that we hope to add are the ability to interact with those logs. So you heard me mention that one of the ways in the demo that we might debug a device is to see the logs that it was sending up, either through CloudWatch or telemetry logs from the MQTT broker. So these are things that we want to also be able to have Fleet Hub interact with directly and give you some really great information as to a comprehensive look at the current device state and challenges with it and any issues with it. And then of course the important thing on the other side is how do we allow users to interact with it. So right now you saw that you can actually create multiple applications if you want to inside of Fleet Hub, and these are all going to be interacting with the same set of devices and services that every other user might have. And these can range from any number of different different user types, right? So product managers, IT admins, developers. And so all of these will all be able to interact with one or more Fleet Hub applications to be able to monitor and manage your devices. So just to recap, Fleet Hub is a simplified way of being able to really easily monitor and manage and streamline your workflow of your devices. It integrates with all of the existing AWS IoT services. That's really important. So this isn't a separate offering, something that's isolated, that's going to be a unique way. If you already use AWS IoT today, it integrates directly with those services. It sits right on top of it to make your management process easier right out of the gate, with no code and very little setup, just a couple minutes to get started, and again, fully managed. And so we ask that if you're interested, please join the preview, provide any feedback. And so before I go, I just want to quickly recap too. One last thing is that we're really going to be adding some great new things to Fleet Hub in the future. You heard me talk about taking corrective action through IoT jobs, the ability to update devices, again, through jobs, as well as being able to access device logs and much more. And we think this will be a great single pane of glass way of looking at your IoT devices, your fleet, and managing them and making your jobs and your overall processes a lot easier. So with that, I just want to say thank you so much, and we really look forward to seeing how you're using it and looking forward to seeing you guys in the preview.